Hello, welcome to my video, chapter 3 and 4, lesson 3. So here we're talking about solving exponentials with a common base. And so we have to remember how to change the base of powers, as maybe you remember from our exponent laws in Math 10C. And so if we take a look here at this very simple example, how do we solve this? Well, I'm not going to do this every time, but if you remember, this is a prime factor tree here. So then you take all of the prime numbers and you notice there's 3 3s. So we write it like this. And then we write it like that. Now we can say it's a power to a power rule. So we can write it like this. We're multiplying because it's a power to a power. And then a negative power means we do the reciprocal. And so there we have an answer. Okay, so with that concept in mind, we are able to solve exponential function, or equations, I should say, with the same base, or solving them if they don't have the same base, but we can make them have common bases. And if they have common bases, then we are able to bring down the exponents and just say that they're equal. So let's talk about it here. So in this example, we already have a common base. So if the common bases are the same, that must mean that the exponents are equal to each other. So we can say 12x minus 2 equals 6x plus 4. Okay, so that's the setup. Now we're going to solve for x. So we're going to move the 6x over, so it's going to be 6x. We're going to move the 2 over, so it's going to be 6. And we're going to divide by 6 on both sides, and we get that x equals 1. Okay, so if this is how it works, if you could go ahead and pause the video now, try the other two examples, and see if you can get it yourself. Okay, so let's go ahead and try this next one. Now, you'll notice that these do not currently have the same base. We have a 4, a 16, and a 2. The trick is to look for the thing that is a prime number. And so the one that's a prime is the 2 there. So we're going to make these other ones match. So this one is, the 4 is 2 to the 2. The 16 is 2 to the 4. And this one is, we'll write 2 to the 1/2 because it's a square root. Okay, so we're just going to simplify this. It's going to be 2 to the 4x minus 6. This is 2 to the 20 minus 28x times 2 to the 1/2. When you multiply two things with the same base, you add the exponents. So we can write it as this. Plus 1/2. And now because they have the same base, we can just look at the exponents and say the exponents must be equal. And so we get 20.5 minus 28x. We're going to continue this over here, which is going to move the 28 to the left. So we're going to have 32x on the left. We're going to move the 6 over to the right, so it's going to be 26.5 on the right. And I don't really want to bother calculating that. I'll just leave it as a fraction, although I could probably make it a very much nicer fraction if I just double it on the top and bottom. So 26 is 52, so 53 out of 64. So you could find a decimal answer if you wanted, but we're just going to end there. Okay, here's another one to try. So here we're going to notice that none of these are prime numbers, but what we can do is we can notice a certain set of numbers here. And one thing I want to just kind of say off to the side here is you should know your squares, like your perfect squares, all the way to 12 squared you should have these memorized, right? Like this is 1, this is 4, this is 9. But not only should you have your perfect squares memorized, you should have your perfect cubes memorized all the way to 5 cubed. And you should also have your perfect fourths. So 2 to the 4 and 3 to the 4. We should have these 3 memorized. 1, this is 81, this is 16. And then after that, really, just anything after is just going to be always to the with a base 2. So all the base 2 numbers we should remember because they are like storage numbers. They're computer numbers, right? So if you look at base 2, it's 1, 2, 4, 8, 16. And if you think about this is like phone storage or memory or RAM. All kind of fit in these sorts of sets of numbers, right? And you could keep going from there, but it's because computers use binary, and so they're base 2. So anyways, I just want to remind you that you should probably have those memorized. If not, that's all right, but just try to start recognizing these numbers. So the 27 is going to be 3 to the 3. The 8 is 2 to the 3. The 81 is going to be 3 to the 4. The 32 is 2 to the... Oh, did I make it one higher? Sorry, I want to make this one 16. Because I want it to be the same as the 3. It should be possible both ways, I think, but this one would be much easier. Okay, so this will be, so because they both have the same exponent, we can then write it like this. And same thing over here. Now, because they have the it's a power to a power rule, we can go ahead and multiply those. All right. And then from there, we can recognize, hopefully, that we can drag down the exponents, making them equal. We're going to get 6x on this side. We're going to move the 4 over. So it's going to be 16 on this side. And so it's 16 over 6 is x. Okay, one last question to try. I'm going to actually make it fit better on the screen. One last question to try. I recommend you pause the video now and try it out for yourself. Okay, so a certain isotope undergoes radioactive decay. We're looking for what the half-life is. This is the final amount, this is the starting amount, and it's after this many years. So we want to set this up. So it's going to be 480 equals 120. This is using that idea of the half-life formula over P, which is kind of similar to what it is on the formula sheet. I think we might just have an R here on the formula sheet or something like that, but same idea. So we're going to make this, because it's a half-life, that's going to be the rate. And then it's 21 years over the period, the half-life. So we're going to solve for that period. So we're going to move the 120 over, so 480 over 120. Oh, sorry, I wrote it backwards. This is going to be 120 over here it's actually decreasing, it's decaying, right? So it starts with 120 and it finishes with it starts with 480 and finishes with 120. Okay, and it looks like this. Okay, and when we solve this or simplify this, it gets us 1 over 4. Yeah, 1 over 4 on that side, and this is 1 over 2 here, which we can simplify to 1 over 2 to the exponent 2. Okay, and now we can drag this down. So it's 21 over p, and so we can make the p go over here, 21 over 2, and so we have 10.5 years. So that's the half-life. All right, I hope this video helps you better understand the idea of exponential functions or equations with a common base, and good luck.